Okay, today I would like to introduce the concept of the slope of a tangent by definition using the limit definition of the slope of a secant line. So we've talked about this quite a bit now, that as 2 points on a secant line get closer and closer to the point on a tangent line, that the slope of that secant line becomes closer and closer to the slope of that tangent line. So now we're going to make that formal calculus definition. All right. Let's go. And here we go. Okay, so I have 2 points on a function. The red graph is the function itself, so let me go ahead and label that. The red is the function. Purple is the tangent line, and the green is the secant line. So we're going to talk about the slope of the secant line. So I will use this thinner one here. So basically what we have is this little rectangle that you should be very, very familiar with, our rise and our run. And rise is the change in y, which is always y2 minus y1. So let's look at that. y2, this is my second y value, minus y1, there it is, in function notation, all over my second x value minus my first x value. So this is the slope of the secant line. Between those 2 points. Now, our point earlier was as the second point gets closer and closer to the first point, the secant line gets closer and closer to the tangent. And it doesn't matter whether it's approaching from the right or approaching from the left. Doesn't really matter. So, then my argument, and what color was the tangent of purple, so we'll go with blue, that the slope of the tangent line then is going to equal the limit as x, my second point input, approaches the first one. So as x approaches a, again, let's look at that one more time. Here's the x value. So as this x value approaches this a value, the points are getting closer to each other as x gets closer to a. That's what I've written here. Then the slope of that secant line is going to get closer and closer to the slope of the tangent line and will actually equal the tangent line. So that is my definition of the slope of the tangent line. Definition 1. And let's use this to find an equation of a tangent line given a function. So what I'd like to do is we'll come up with a function, nice easy one, y equals x squared. And just a quick rough graph, just a real tiny little rough graph. It looks something like that, a parabola. And I'd like to find the equation of the tangent line that goes through this point here, which is 1. I'm going to plug in 1 squared. The y value is 1. So there's a tangent line of this function going through the point 1, 1. I'd like to come up with the equation of that tangent line. So first of all, let's look at the slope of that tangent line. The slope of that tangent line equals the limit as x goes to a of f of x minus f of a all over x minus a. So here we go. F of x is x squared minus f of a, plug in a for x, you get a squared all over x minus a. So the slope of my tangent line at a, actually in this case we have it at 1. I'm just going to go ahead, yeah, we can do that. So a is 1. So as x approaches 1, x squared minus a squared over x minus a. Now, what I'd like you to notice is that the top is a difference of perfect squares, which means the top can be factored. Into x minus 1 times x plus 1 all over x minus 1. Now, I know I can reduce this limit by taking the top and reducing it with the bottom and not change the value of the limit. Giving us, as x approaches 1, of x plus 1. Now, this is a polynomial function. I know I can use direct substitution of a polynomial function. So I can plug in 1 for x and solve. And the slope of my tangent line is 2 when x is 1. So I have found the exact value using the limit definition of the tangent line. So there we go. I've got a point at 1, 1, and I've got a slope of that tangent line is 2. Now, if I have a point, oh, sorry about that. Everything just got erased. Let's see if I can back that up. There we go. So, if my slope is 2 and I have a point, then I can use the point slope formula, which is y equals m times x minus x1 plus y1. That is your point slope formula of a straight line. You should know it by heart already. Oops, let's make this bigger, not smaller. And come over here. So I'm going to plug in my point and my slope. So my slope is 2, x minus the first x value plus that y value. There's only one x and y value on here. You can simplify this if you like. And now, not only did I find the slope of my tangent line, I was able to find the equation of my tangent line because I had both a point and a slope.